I'm here with Nancy Kiang of the Goddard Institute for Space Studies in New York City, who is a bio, you tell me,
Biometeorologist.
biometeorologist. And exactly what do you mean by biometeorologist?
I study the interaction between living ecosystems on land and the atmosphere.
Okay. And so we've been discussing photosynthesis here at the Beacon 2023, and it's we're in a verdant, beautiful island of La Palma, the Canaries, and hearing all sorts of astrobiology talks. And one key aspect of this conference has been the quest to find exophotosynthesis. So, Nancy, can you tell us a bit about what it entails to look for spectra that would indicative of photosynthesis on a Earth-like planet circling another sun-like star, and what we understand about the pigmentation of the plants here that enabled the onset of complex life.
So you see behind me all this wonderful green vegetation.
Uh-huh.
So that color is due to photosynthesis, which uses chlorophyll, which is a green color. And that photosynthesis produces the oxygen in the atmosphere that we breathe. Both that color of the plants, which not the green, in fact, it's actually a reflectance in the near infrared, which our eye does not see. There's a reflectance in the near infrared, and the oxygen in our atmosphere are both a sign of photosynthesis and a sign of life on our planet, because there are no geological or abiotic processes that could produce either that reflectance or the oxygen in our atmosphere. So in the search for life on other planets, we would like to look for oxygen in the atmosphere, and if possibly there were times on our planet's history when oxygen was not quite abundant enough for an atmosphere for, say, space telescopes to detect, but maybe the pigments on the surface of the planet would be there. Or if there's oxygen and there's simultaneously pigments we can see, that's a strong evidence that there's photosynthesis on that planet. Now, it's not all planets orbit stars like our sun. Our sun is a yellow G star, but there's stars like M-dwarf stars that have their light spectrum shifted over to the red and near infrared. Now, photosynthesis on Earth largely needs a visible light to do photosynthesis, but on M-dwarf stars, there's not that much visible light available. So it would be advantageous for photosynthetic organisms to make use of the more abundant near-infrared or red light instead. So they could have colors of pigments, light harvesting pigments absorbing in those far red and near-infrared wavelengths instead, and that could be a different sign of photosynthesis on
And
those
this
planets.
is important because red dwarfs, M dwarfs, are considered to be make up 60 to 70% of the stellar populations.
Yes.
Initially mainly around our own star, but in the galaxy itself. And so let's hope that eventually, maybe in 10, 15 years, we'll have a $10 billion telescope that's designed to specifically look for this photosynthesis, and maybe you'll be part of the science team.
Could I conclude with one other note that you didn't hear from me before?
Sure, go ahead.
It's that so M-dwarf stars have various liabilities for doing photosynthesis or life at all.
Chromospheric activity.
There's also K stars that are midway between G stars like our sun and M-dwarfs. That could be like in a nice mean where there's both good light for photosynthesis as well as lesser liabilities like UV fluxes. So on our planet, we actually have other examples of oxygenic photosynthesis, not using chlorophyll A, but using pigments called chlorophyll D and F that are using longer wavelength, redder photons. So these could possibly become more dominant on another planet. And also it tells us one thing: our planet's not static, it is evolving, and we don't know, perhaps in the future our planet might shift in color for aliens seeing us sometime in the future.
So if it did shift in the future, what exactly do you mean?
Our red edge might not just be in the red anymore, it might be shifted to maybe
even further
in the near infrared.
Is that right? Okay.
Yeah.
All right. Well, listen, thank you so much for your time today. and more to come on Forbes.